Hi everybody, Patrick here from EngineeringShock.com. What this is one of our newest products. It's a kit we created. We're selling them in modules and as kits. What it is it's an electronic safe using a variable resistor, a 7-segment display, a PIC 18F, and a relay, a buzzer, and some other fine components. The kit is right here. This video is to serve as an instructable, so that you can determine how to put it together. And if you wanted to put one of your own together, if you had the parts, then you could do it yourself if you wanted to. So what I'll do is I'll give you a quick demonstration. We'll talk about putting the kit together, or the parts together on the PCB. We'll talk about the schematic, we'll talk a little bit about the code, and then what I'll do is I will hook it up to AC to show you how it works. Okay, so how this works is, this variable resistor is connected to the analog to digital converter on the PIC 18F chip. So I'm able to make selections of digits using analog voltages created by this variable resistor. So I'll turn on power. So right now I'm at a 7, so I'm going to lower the voltage by turning my variable resistor, emulating a safe. So it goes from 0 to 9. So let's choose, what you do is on power on, you choose a code. In this case what I'll do is I'll choose a 0, 1, 0, 2. Now notice that it gives you a beep telling you that that the code's been inputted. So actually, first of all, well, I'll just give you a quick demonstration of the different features. So first of all, let's actually just do enter the right code. So now it's searching for the right code. I'll press 0, and you can hold that button down as long as you want. And the indicator will just tell you that it's picked up. Alright, so now you might have heard a little click there. We just entered in the right code. Our relay's turned off, so we can control AC using this terminal block right here. We've got normally open, normally closed, and our common pins of our relay. So what we'll do is we'll hook this up to some AC stuff later on. But right now, we've entered in the right code. Got a fancy LED scroller saying, hooray, you've entered in the right code, you can enter, you can do whatever. You can hook up a solenoid and make this so that you can enter and exit a door using this module. So now, we've entered our door, we've done our thing, we've turned on the light, whatever you chose to do. We'll press our select button again. The indicator will go off saying, okay, we realize that you've pressed a button, and it'll go back. Now it'll search for that code again, 0102. Now there's a timeout period as well. So let me just say I take way too long to enter in a code. I entered in one digit. Give it a second. And that means that the count has started over, so you have to enter in the 4 digits from scratch again. So let's enter in the wrong code. Let's just do 2222. And that will stay like that until you press the select button again. After you've programmed in your code, in this case 0102, that is the only code that will activate the relay, which will activate your output. So a little bit of the theory behind it. We've got our 7-segment display pins connected directly to our PIC 18F, and we're actually using the PIC 18F not to source power to the common anode display, but rather sync it through the I/O ports. We've got, on each pin we've got a 470 ohm resistor protecting the LEDs through current limiting. We have our 10K variable potentiometer connected to a VCC, which is 5 volts ground, and our ADC pin. So that's feeding the variable power to our ADC pin. We've got our buzzer and indicator, our LED indicator. You need more than 7.5 volts for this, or 7 volts for this to work properly. 6.5 volts will probably be okay, but 7 volts plus because we've got a 7805 regulator here. So I'll get to the schematic in just a second. But first of all, let's actually go through and I'll show you how to put the kit together. Okay, so here are the parts. You've got 9 470 ohm resistors. They're all current limiting. They're used for the 7-segment display in your indicator LED. 2 10K ohm resistors, a 5 volt relay, a 10-turn 10K variable resistor for your safe emulation, a common anode 7-segment display, 2 terminal blocks, a 2-pin and a 3-pin, an 18-pin socket, a PIC 18 programmed microchip, a 5 volt Piezo Buzzer, 1 LED, 1 diode, 1 tactile switch, a 780550 regulator, a 10 microfarad polarized capacitor, 0.1 microfarad capacitor, ceramic, and a 2N222 NPN transistor. Now, it doesn't come with wire to connect this to the board. You'll have to come up with your own wire, but you can use really any kind of wire as long as you solder the right pins to the right external pins of the board. But we'll get to that. So what we'll do is we'll just start soldering. First of all, we'll put in our passive components, so our resistors, transistors, capacitors, LEDs, diodes, and then we'll get to the bigger stuff. Okay, so I've just placed our 9 470 ohm resistors on the board. Each resistor, in fact every component, is very well labeled, so you shouldn't really have to follow you through with this, but there are some little design notes that you should take note of. So what I'm going to do is now I'm going to put my two 10K ohm resistors right here and right here, and then we'll do the capacitors, then we'll do the diode, and then we'll do the bigger stuff. Okay, so in that step we soldered our two 10K resistors right here and right here. And we also soldered in our single 0.1 microfarad capacitor, and that's actually labeled, the capacitor is labeled 104, standard. 0.1 micro is a decoupling capacitor in this application, and again it's labeled 104. The capacitor is labeled 104. So now we're going to start talking about the capacitors that have a polarity. We've got our LED, a light emitting diode, our 10 microfarad capacitor, our diode, and our Piezo Buzzer. Now let's talk about these quickly. The diodes are very similar, however they've got different indicators. The negative of the standard diode, the 1N4004, has a white side and a dark side. The dark side is the positive side called the anode. The negative side that has the white stripe on it, and you might not be able to see it very well on here from this angle, is our negative side, which is our cathode. Now if you look at the board, there is our 1N4004 diode, and there's actually a white indicator on this side that says this is where the white side, the side of that diode, is supposed to go, and so we just have to match that up. But next, we've got our LED. The LED has a couple different indicators of the positive and the negative side. The anode has the longer pin. The cathode, which is the negative, has the shorter pin. So if you actually look at the side that has the shorter pin, there's also a flat surface on the mask of the LED, the red of the LED. And so what's actually happening here is on our footprint, this is the most difficult footprint to look at, because there is a flat indicator on the footprint as to which side is the negative. In this case, the negative is actually facing down. So place the shorter lead into the bottom lead here, and your longer lead, which is your positive, into the one facing the resistors. Now lastly, we got our electrolytic capacitor. Very similar. The negative pin is shorter, the positive pin is longer. Now we've got an indicator on the board right here, and there's a little plus sign saying where the positive should be placed. So on the left side here, where there's a positive indicator, we're going to place the longer of the two pins, and we're going to place the shorter of the pins in the rightmost side. That is the negative. So let's place these components in, and then we'll talk quickly about the Piezo Buzzer. Okay, so we've placed our electrolytic capacitor, our LED, and our diode. Last polarized component is our Piezo Buzzer. There is a plus symbol indicating the positive. Like some of the other components out of our Piezo Buzzer, there is a positive lead, which is longer, and a shorter lead. So we're going to place our positive lead into the positive indicated pin, and then we're going to solder it. Now we're going to solder in our two terminal blocks, our monetary push switch, or selection switch, and our transistor. Now there's a note for each of them. For our terminal blocks, make sure that the terminal screws are facing outwards, because if they're facing inwards, you're going to have a lot of problems. I'll show you what I mean after I've soldered them in. Our tack switches, they only fit in one way, so you shouldn't have too many problems with the tack switch. On the left and right hand sides, they've got leads that are close together, so you just have to fit it in and solder it. Now our NPN 2N222 transistor, that has a little bit of a note. On the board, there is a flat side of the transistor, as a bird's eye view, and there's a curved side. You have to make sure that the flat side is matched to the flat side, and that the curved side is matched to the curved side. Okay, so we're going to make this step. This is going to be the third last step. We've got our last four main components, our 7-segment display, and how we fit that in. There's actually you see this dot right here. There's a dot indicator in the lower right hand corner, and on the footprint there's a dot in the lower right hand corner. So we just have to match that up. Don't reverse it or else the circuit will not work. Just have to place that way. So the relay has 5 pins, and it only fits in one way. So that actually fits in quite easily, and you have to solder that as well. We've got our 7805. Match it up to the picture, so it fits in like that. And you've got your socket. Now the socket, pay close attention to this, because you don't want to when you put the chip into the socket, you want to make sure that everything's oriented properly. There's a little right above the IC2 indicator. There's a little notch. That is an indicator as to which way the socket and the chip should be put in. So if you look at the chip, there's a little notch on one side too. So make sure that you line that up properly before you solder it in. Do your soldering. We'll do the last final steps. Okay, this step is easy. You've got your PIC18F chip, your socket soldered in. We just have to match up this. On the chip there will be a little notch as well that matches the notch on the socket and on the board. We just have to match that up, place that in. It'll be on our final step, and then we'll test it. We'll talk about the schematic, and then we'll do a nice big test with our newly soldered board with an AC source. This is a 2-part step. As I said, this kit does not include the wire. You just need 3 pieces of wire. You don't need to color code them, but if you were to color code them, I'd suggest using red, black, and another color. So first of all, what we're going to do is we're going to solder the red wire on one side to our VCC pin, which is our 5-volt pin. We're going to solder our black wire to the ground pin. And we're going to solder, in this case, a yellow wire to the ADC pin. Now remember, this variable resistor acts to provide different voltages to the ADC of the analog to digital converter of the PIC18F chip. So what I'm going to do is I'm going to solder to that, and then we'll solder to the variable resistor, and then we'll power it up. Okay, so now we're done. I've connected the ground pin to the pin closest to the head of the variable resistor, the ADC pin to the back wiper, and our voltage VCC pin to the middle set of pins here. And so now what I've done is, on the board, our power terminal block is labeled V plus and ground. V plus has to be preferably more than 6.5, but labeled more than 7 volts. So I'm going to put 7.5 volts on it, turn it on. That's a good sign. So now what I'll do is I'll start twirling this around. Make sure that the select button works. Okay, that's working. Our Piezo Buzzer is working. And our relay is working. So let's just put in the wrong code. Everything seems to be working just fine. Hope you like this. Now we're going to quickly talk about the schematic. Then we're going to hook this relay up to some AC stuff. Okay, so I'll make this PDF available on Instructables.com and on our website at engineeringshot.com. But I'm going to go through this with you. I know that it's very small, but I'm pretty sure as I go through it, you won't have any trouble following along. Let's start with the power source. You require 7 volts to regulate to 5. We've got our 5-volt regulator here, our input terminal block, the ground pin of our terminal block, and our V plus pin of our terminal block. We have V plus connected to pin 1 of our 7805. The second pin of the 7805 is connected to ground, and our the third pin of our 75 is our 5-volt regulated output. That controls everything on the circuit. We've got 2 protection capacitors on here. One's a smoothing and one is a decoupling. The 10 microfarad, that is an electrolytic, is a smoothing capacitor. If you're using a battery at the input, you don't even really need it, but it's there just for the sake of, in case you want to use a wall regulator for your input. And the 0.1 microfarad capacitor is a decoupling capacitor. It's just for filtering effect. So that is our power circuit. That will power our PIC. It will power our buzzer, through the PIC. It will power our 7-segment display, and it'll power our relay. So basically, we just have a whole bunch of peripherals that are connected to our chip. Our chip has a power source from VCC, which is 5 volts, and ground. We've got a Piezo Buzzer that is connected through our PIC directly to one of the I/O ports on our pins. We've got a button here with a pull-up resistor on it. So what happens is this is our selector button, and because we've got a pull-up resistor, a 10K pull-up resistor, the input of that pin is always seeing 5 volts, so it's seeing a high. However, when you press the button, it grounds that signal, and so the input, when the input is scanning, it will see a 0 volt, and that will trigger an action. Okay, we've got our 5-volt relay. We've got a 10K resistor that protects the base of the transistor. This is an NPN transistor, so it turns on when a positive pulse, a 5-volt pulse, hits it. So when 5 volts goes along this line, it triggers the base, and all the power at the collector is sunk through to the emitter, which is connected to ground. So this is our relay coil, which is connected to 5 volts. So when you add a supply power to the base, power is sunk through the coil, through the transistor to ground, which creates a magnetic field along the coil, which triggers our relay pins, the common pin, the normally connected pin, and the normally not connected pin. We'll get to that in a second. However, there is a protective diode here, because when you take away power at the base, when you turn the transistor off, the magnetic field on the relay coil collapses, creates a huge voltage spike, which is why we have this diode here. It protects against those voltage spikes. So your PIC and your power supply and everything will be okay. It'll be protected against those voltage spikes. Next, we've got our Adc pin, which is connected to the board. You have to connect the wiper of your potentiometer to it. And we've got two other. We got our VCC hole that we soldered to, and we've got our external ground hole that we soldered to connect our variable resistor. Next, we've got our 7-segment display. It's a common anode 7-segment display. We've got 2 pins connected to VCC, which means that all of the internal anodes are connected of the 8 diodes inside, or LEDs inside. They're all protected using 470 ohm resistors. They're current limiting. So all 8 lines are connected to I/O ports at the PIC. So when the PIC through programming tells it'll sync power from the power source through the anodes of the LEDs and through certain resistors back through and internally to ground through the PIC. That will turn on and off LEDs. Okay, so when you activate the relay, the common pin, which is the middle pin, connects to the normally open pin. By default, the common pin is connected to the normally connected pin, the NC pin. There are 3 pins, NO, normally open, CO, which is common, and NC, which is normally connected. So as you can see through here, there actually is a connection between CO and NC, so common and normally connected. When you apply power to the relay, the common pin connects not from connects to the normally open pin. So that's how we activate AC. I'll talk a bit more about that during the demonstration. Lastly, we've got a diode here, an LED indicator, and it's protected by a 470 ohm resistor, and when power is applied to that I/O pin, input-output pin, that LED turns on. Okay, now let's do a demonstration. So finally, an example. We've got the common pin and the normally open pin connected to a dollar store extension cord. The hot wire has been cut in half, so one half of that hot wire is connected to the common pin, the other is connected to the normally open pin. The power bar is connected to my lamp, and this is connected to my AC source. So I apply DC to the board. Let's put in, for simplicity, a combination of 8888. Okay, 8888. And the lamp turns on. So, if you're interested in the kit, visit us at electroniclessons.com or engineeringshock.com. Hope you liked this video instructable. Hope you found it helpful. I'll be leaving the code and the schematic in the instructables. So feel free to have a look at it. Thanks for watching.